Good evening, Dr. Sanders. So I will show you my ray tracer textured Java file running first and outputting the sphere, the textured sphere instead of a textured cube. So we run the file. As you can see, this is just vectors getting added and it got saved here, and let's take a look at it. Looks really nice. Yeah, very smooth. And so now we'll go to whatever I did for this project. Um, the first few lines were worked on by Tim, and then I instantiated this helper method called the compute spherical IUV, which is what we use to compute the points for our new sphere. And then Dariel did most of the math. And then this line is just me initializing a new sphere object called closest sphere and initializing it to null. This will be filled up elsewhere right here, where after comparing it, like how we do it in the textbook, comparing the intersections and seeing if the ray hits that inter specific point of the sphere, then the closest sphere gets updated to whatever sphere was in that at that point in the array list. So here we start a for loop that goes through the whole scene, and this is just an intersection object where we initialize our retracer object with it. Um, and yeah, uh, this if statement just checks if the closest intersection is not null. Then we do this vector to spherical UV assigning. And that was just a debug statement done by Daryl. In the next section of what I did, um, here we're defining vector 3 methods. So we first did a multiply, which just returns a new vector 3 object with that is done as a normal vector multiplication, and also vector 3 addition, which returns a new vector 3 with the added x value, y value, z value. And then this line, I just instantiated a new array list of sphere objects called spheres that is used in a lot of places, but mainly in the scene class. It's what we used up here. Um, Up here in this for loop. Whoa, got big. Um, and then the final part of my code, we're just here checking if two things are equal to zero. So if the discriminant is less than zero, then we return a new intersection with all values as like zero, or what you'd call null. And then this is just some math um, that we are doing. And then here we're initializing um, two vector three, uh, two vector three variables. Yes. And then we're adding, and then in the second one, we're subtracting after, while also normalizing. Yeah. And then we return a new intersection, um, that has, instead of false, zero, null, null, has the true point and the t, the heat point, and the normal. And yeah, that is all I did. Thank you very much and have a good evening.